Okay. So what are your plans for tomorrow?
So here's where I'm going to start. So we're going to start by using some kind of markers, and I'm going to have them go through and draw. We're going to talk about the parent graph first,
Okay.
and then we're going to talk about what an asymptote really is.
Okay.
All right.
So
and
be
then,
clear, we're doing rational functions.
yes,
right? Okay.
we're doing rational functions. And then we're going to talk about number one together and draw those in. But I'm going to have them use two different colors so that they can distinguish between them and how we fill this in.
Okay.
Okay? And then I'm going to have them do these. I'll explain that you can have two verticals,
Mm-hmm.
only one horizontal.
Okay.
And then we may do that one together. We'll see. And then they'll do these two on their own.
Okay.
Okay? And then I'm going to ask them about what do they see about the end behaviors, because they have to fill in those end behaviors. And what I want them to notice is that they match the horizontal asymptote.
Okay. So they're gonna try to connect end behaviors with the horizontal asymptote.
Yeah, and I'm just throwing that in there because I just want them to be able to, like, I don't want to just tell it to them. I want them to be able to see it,
Yeah.
and they should be able to distinguish that from there.
Okay.
Okay, that's the first
So
start.
they've had previous experience with end behavior
Oh,
being
yes.
to infinity, to negative infinity,
Yes.
with the quadratics, polynomials, and all that stuff.
Yes,
And so up to this point, they only know infinity as their answer.
correct.
Okay.
Well, they have seen piecewise, some piecewise.
Oh, they
so
have
they
seen
have seen
piecewise,
some
okay.
piecewise. So yeah, so that it won't be anything really completely different for them. Now, whether they remember that or not,
Okay.
we haven't done a whole bunch on piecewise, but they have seen it.
Okay.
Okay.
All right, so you're
Alright.
basically modeling what you do with the parent graph to this.
Mhm.
I like how you're going to use colors here because it's going to distinguish between what they're doing and kind of differentiating
Between the two.
between the two
Mhm.
asymptotes there. Man, I should have used that idea last year when I was doing that. That's actually a smart idea. So what I'm getting is that you are just doing the first four, so you're doing the asymptotes first,
Mhm.
and then you're doing the intercepts.
Mhm.
So you're going to do that with all four of these first.
No, they're gonna do all. We'll do all of it together.
You're going to do all of it together. So,
Yes.
so on number one, you're going to do all of this together.
Uh-huh.
It's in the end behavior
Together.
together.
Yeah.
And then you're basically going to have them do the end behavior on their own.
Yeah, and then
Okay.
they're gonna be able to connect, that the end behavior should match the horizontal asymptote.
Okay. All right. Is
Or do
there
you
a-
recommend that I not do that?
No, I was gonna kind of suggest, maybe give them that opportunity to see what they can get here,
Uh-huh.
because they're gonna see that the lines are converging
Mhm.
towards zero
Mhm.
on the first problem here. I kind of leave that up to an exploration piece, maybe give them something to think about.
Like here,
Giving them
having them
like a
find
couple-
those?
Yeah, giving them a
Yeah.
couple minutes
Mhm.
maybe just to find these and see what they think.
right, and then at the end, see if they can
Mhm.
connect them. Yeah, that's
See
what,
if
that's
they
what I
can
thought I was
connect
gonna do,
Yeah.
to see if there's a connection. Because I thought, well, if they can figure that out, maybe it'll stick with them, that that's kind of what they're looking for.
Mm-hmm.
So,
Okay.
okay.
Is there a back page to that as well?
No,
or-
this is just sort of the intro so that they can see it on the graph.
Okay.
Okay, and then we're gonna move into finding them vertical and horizontal asymptotes from this looks really wordy, I know, but this is my notes,
Uh-huh.
from a polynomial function.
Okay.
Okay, so the rules, talk about the rules, and I'm gonna give them some points on the graphing calculator, how to find those.
Okay.
But without the calculator, that they need to know that it's written as this, which we did over here,
Mm-hmm.
and it's what makes the denominator 0.
Okay.
There's a couple thrown in here where they're going to have to factor. We'll talk about those.
Uh-huh.
We'll talk about what it means when you can cancel out, that it's a whole,
Okay.
okay? And then all the rules for the finding the horizontal asymptote, because there's no calculator rule for
Yeah,
that.
the horizontal asymptote's a little bit harder to
Yeah.
find.
So they're going to fill in the blanks here with this.
Mhm.
And so that way they'll have it that they can refer back to. Okay?
So you're.
And we'll go through these three, and then they'll do those three on their own.
So I like how you have this set up as notes, because, I mean, for academic, you could have kids who have IEPs in there that need this idea for notes and stuff like that, and that's a good thing that you have here. But and they're giving the fill in the blank kind of idea, so they're doing something with these notes.
Right.
I like how you got these, getting them thinking about vertical asymptotes, looking at the denominator. My only concern is about the whole idea. I think they're gonna have little issues with that just because of the fact that we didn't touch it here with the
Right.
graphing. And so,
Well,
I
at
mean,
first I made myself a note that I would talk about this for later.
yeah.
And then and this is sort of just my own,
Maybe your own little notes there for
Yeah.
that.
yeah. It could be that, because they're gonna have to know it.
Yes.
So on the back of this page
Okay.
comes into the discontinuities. And then this shows us where they're non-removable and removable.
Gotcha. So basically taking the idea of factor form, looking at the two, okay, I got an x plus 2, I got an x plus 2 on the top and the bottom.
Yeah.
That cancels, so that means I have a hole at this end. Okay.
So I may just go and just say, oh, well, we noticed that these cancel. I'll talk to you about this here in a minute.
There you go. Okay.
But if it doesn't cancel, it's a vertical asymptote, and where it doesn't cancel is the actual vertical asymptote. And then back here, talk about the removable and non-removables, because it is on the discontinuities. It's on the next sheet.
Yeah. This here, you know, knowing that there's a hole there is probably better when you see that visually in the graph, where you see that little open dot, so that they can actually see, oh, okay, there is an open dot, and we can see that's a hole.
So maybe I need to draw it and show them what it looks like.
See, I that might be an idea, maybe for the notes, to kind of get this idea. So maybe have them little draw a little graph saying, okay, so that if I have this line going like this, and I have this hole.
Show it to them on the school year, school day.
So
Okay.
probably a good idea is to show how the graph would look. So like if I'm like, not like how this graph looks, but it's basically it's explaining to them
Let's see.
the idea of that to them. So giving them
Let's
an
see
idea that there's an open dot there.
Let's
at
see
that
what we can do with it. Because I mean, we could easily graph that one, and that one shows it there, but it's going to also have it's going to have a hole
It's gonna have a hole at 2.
at 2,
And doesn't
which is going to be
calculators
right
don't
there.
show
No,
holes very
calculators do not show holes, so I would have to show them that there's a hole right there. So I don't know that I could do that over here
well. Yeah,
and show them this. Oh, no, this one.
yeah.
And show them that there's the removable hole.
Because
there.
this is gonna come out as a linear
Yeah.
as a linear equation. So at -2 there is gonna be a dot there
Yeah.
at -2. So I would suggest that for academic
Okay.
sense, because they're gonna be like, what is this vocabulary that she's talking about right
Yeah.
now?
Right.
That's what I would suggest, is maybe giving them a little visual idea behind the hole, so that there's
Yeah.
some kind of
Right.
something to go along.
And at some point, I need, and they'll see it down here, that it's okay to have a hole and a vertical asymptote,
Yes.
that they're gonna have both. So once we get through this, then I'm gonna have them practice these, and it's gonna have both.
Okay.
So they're gonna be able to do both there.
Okay.
Okay?
Looks good.
Okay.
Yeah.
Good.